Okay, here we are going to start partition. Partition has a very large application in quicksort. Quicksort is basically based on partition, which is very quick. That's why its name is quicksort. So we are going to show the first method how to do partition. Okay, so this is very simple way. Consider any of these elements as pivot. What partition means is something. Consider any of the element as pivot. Let us consider 4. So considering 4 as pivot, so at the end of partition what should have been done is 4 should have been 4 should reach to its the position where it should belong in a sorted array. If this was a sorted array, the 4 should have been belong to the fourth position, because 1 2 3 4 fourth position. So at the end of partition 4 should reach the fourth position, and the left half of the 4 should contain only those elements which are smaller than 4, and the right part of the 4 should contain only those elements which are greater than 4. And we will see how this can get implemented. This was the basic introduction to what is partition. So let us start. So partition, actually this is the first way how to do partition, and there will be second way which will come in the next video. So in this way we simply do nothing, just consider this as pivot. There is a conventional way of that the first element is considered as pivot. You can consider any other element also. So we are considering 4 as a pivot, so we compare 2 with a pivot, and we also consider one other counter that is named just as counter, which will have its application and you will know it. So let's start. So counter and pivot and I, all the 3 are pointing at 4 right now, and we increase I to 2. We compare 2 with the pivot, that is 4, and we see that 2 is smaller than 4. If 2 is smaller than 4, we will interchange the counter and I. Okay, so the counter was at 4, so we will interchange these two. Now pivot always goes with the 4, because 4 we have considered 4 as a pivot, so pivot always follows 4 only. Counter is incremented by 1 for every interchange, and it is not incremented if there is no interchange, that has no interchange has taken place. So the counter comes here, and the pivot comes here, and I goes here because I increments every time. So as 6 is larger than 4, so no interchange required, so pivot is here, counter is here, and I goes here. Now we compare 3 with 4, and 3 is smaller than 4, so we will have to interchange 3 with the counter. So counter was here, so we will interchange these two elements, and 3 comes here and 4 goes here. Now counter increments by 1, so counter comes to 6. This is the place where counter is right now. This is the pivot, and this is I, because I increments itself every time. So now this is I. Now we compare the I with the pivot, and as 5 is greater than 4, so there will be no interchange. And then we compare pivot with 1, as 1 is smaller than the pivot, so there will be an interchange, and the interchange takes place with the counter. Remember this, interchange does not take place with the pivot. So this will be the interchange that will take place, and this will come here. And now you can very easily see that these 3 are smaller than 4, and these 2 are smaller than 4, and 4 is in its correct position. But this was a case in which 4 comes to its correct position, but sometimes 4 does not come to a correct position. You might have, at the end of the loop, you might have got this kind of situation. In that case, you have to, at the end, because counter will increment itself to 5, after interchanging, counter is here. So what in the end you have to do is interchange the pivot and the counter, and 4 will reach to its original position. So that is another case. This was a case in which 4 already comes to its position, and just keep that in mind also. And thank you. This is the first way how to do partition. Thank you.